The Diagnosing Herbicide Injury course provides learners with a basic guide to diagnose and investigate crop injury situations known or suspected to be related to herbicides. The course gives them the tools needed to facilitate the investigation process. Learners are guided by an animated character modeled after and narrated by one of the subject matter experts, Dr. Brad Hansen. While designing the course, we strive to include a diversity of approaches to present the content. So while some screens contain images with audio narration, other screens include video segments, animations, many diverse interactions, and knowledge checks. The course is divided into 7 modules and takes about an hour and a half to complete. In order for learners to get continuing education units, CEUs, for taking the course, the accrediting agencies require that the course meet certain criteria. The time learners spend in the course must correspond to the number of awarded continuing education units. Therefore, learners must go through all of the modules and cannot skip any screen. The next button becomes active only as the narration of a given screen ends. A moving bullet at the bottom of each screen shows the progress. However, learners cannot use this as a slide bar to fast forward. In several sections of the course, learners can choose in which order they will proceed through subtopics of the module. In those situations, they return to the junction screen after going through each subtopic and can only proceed further in the module after watching all subtopics. Icons of the sections already visited become grayed out and a green checkmark appears. The Introduction module offers a review of reasons and situations when the use of herbicides is justified and explains implications of herbicide injury. To get learners engaged, we have included 2 interactive screens in this module. In the first one, learners click on a plant part and see an example of how that plant part may be affected by an herbicide. In the second interaction, 2 images of similar symptoms caused by different factors are presented. After clicking on each image, information about the cause of the symptom is revealed. Module 2 presents what different pathways of herbicide absorption and symptom patterns reveal about the herbicides that may have caused the injury. We present side-by-side time-lapse videos of injury from 2 different herbicides on the same weed species. The individual videos were produced by The Ohio State University, and we have received permission for their use in this new way with an added timer. These time-lapse videos clearly demonstrate the importance for recording the progression of injury over time to assist with narrowing down the possible herbicide culprit. In the 3rd and 4th modules of the course, we focus on patterns of injury in the field that can help investigators determine how herbicide damage may have happened. The 3rd module focuses on uniform or repetitive injuries across the field, while Module 4 addresses variable injury patterns, such as patchy areas of crop injury, and a gradient of damage along a row or from the edge of the field. In Module 4, we have implemented 2 different ways of presenting textual content, in the form of tabs and in the form of an accordion. Both of these are Adobe Captivate interactions. The interaction explaining how far droplets can travel was designed by the course developers. After clicking on each option, learners can see whether their guess was correct. Lastly, Module 4 also includes 2 animations created by the course developers, graphically depicting leaching and runoff as possible causes of herbicide movement. Learners can see how a pesticide moves to unintended areas after rainfall. The 5th module focuses on the correct vocabulary to describe the different herbicide injury symptoms. We present an extensive photo collection of symptoms. Learners can click on each image to enlarge it. In this module, we also introduce the UC-IPM online herbicide symptom search tool and present a brief tutorial about how to use it. In Module 6, we present good practices to follow when collecting soil and plant samples for laboratory analysis. Not only do we discuss how to send samples to the lab, but we also include how to select a certified laboratory that performs specific tests and how to interpret analysis results. In Module 6, we included a non-binary person of color as a laboratory technician. Finally, in the 7th module, we provide a summary of herbicide injury diagnostics with a checklist of steps to follow. We strive to make the course engaging and entertaining. To keep the learner's attention and lighten the serious tone a bit, we have included some fun actions for the animated character, such as making screen content disappear with a snap of his fingers, or having him fly into a scene. Throughout the course, learners are presented with review questions. These knowledge checks do not count towards the final test score, but reinforce learning. At the end of the course, learners must pass a 20-question final test. Questions are randomly drawn from a question bank so that each attempt produces a different version of the test. To meet the CEU requirements, learners must pass with 70% or more. To comply with accessibility standards, we implemented essential elements such as sufficient color contrast, navigation through screens using the keyboard-only interface, alternative text for images, and closed captions for all narration and video segments. The course was well received by subject matter experts and the target audience. Within 3 months of its launch, 169 participants successfully completed the course and provided positive feedback.